Hello everyone. In this video, we'll see how to build a linear regression using Python. So we'll see what are the packages we are going to use in this demo. So one of the package which we are going to use is sklearn. It is a simple and efficient tool for predictive data analysis, right? Which is widely used for ML modeling, right? So whenever you say, right, so when you are learning a machine learning or data science with Python, you will definitely touch a scalar. This is one of the best machine learning package available for Python. The another package which we are going to use is pandas. Of course, this is also one of the best package for ETL. So sklearn is mainly for machine learning modeling, where pandas is mainly for ETL. So like, what is ETL? So it's extraction, transformation and loading. Right? So the data will be in the different sources, right? The data might be in a file, it can be in a the database, ERP, it may be in some APIs, right? First we need to extract the data from different sources, and then I need to apply some transformations, which is nothing but some data pre-processing steps like data cleaning, right? So understanding the data, whatever, right? So that we do in transformation. Once we got the final data, the clean data, and then I load it in some other systems. It can be file, database, or any other system. That was a typical ETL does, right? So the other package which we are going to use is a Seaborn. This is actually used for visualization, right? Now coming to the point, right? So to build any machine learning model, first we need some data, right? For this data, we'll use some toy data that is provided by sklearn, right? So we'll go to their site and see, right? So yeah, so these are the some sample data which sklearn provides, right? So actually the reason why they are providing the data set is, right, for the beginners, right, who just started learning the data science, it will be easy for them, right? So these data sets are hands-on. I mean, it's available ready so that they can simply take this data and try different options, right? So the data set which we are going to use in this demo is this Boston data, right? So we have almost 506 records, and we have 13 numerical and categorical values, and these are the list of variables or columns which are available in this data set. So we are not going through each and every one of this variable, what it does, why it is. So our intention is just to understand how we can build a machine learning the linear regression model using Python. Right, now I will click this. Yeah, so this is the one which, so in sklearn under data set, right? So this is the one where my data is available, right? So let me try to import that package. So from sklearn data sets, what I need to import is a load Boston. Now I need to store this data in one of the variable. I'm naming it as a data. If you see this, if I try to print this, I have the data, which is my independent variables, target, which is my dependent variable, and the name of my independent and dependent, columns, name of the columns of my dependent and independent, right? So now what we'll do is, so now we'll use pandas here, right, to create a data frame. So pandas is like a two-dimensional array, right? So if you worked on the databases, like MySQL, Oracle, right? So when you say select star from the table, right, so you'll get some data, a clean understandable data, right? So the column oriented data, we have columns and rows, the same thing, right? So this data using pandas, we are going to convert to the columns and rows, so that it will be easy for us to understand and perform some data manipulations on top of that, right? So let me import the package import pandas as p. Now data maybe linear regression is equal to, so ed dot, I need to create a data frame on what, and this data, right? So let me try to understand few methods available in this. Okay, one is data. Okay, so this is the data, right? So the another important thing is feature names, which means, see, this is my data, right? It's an numpy array, a list of a list, right? Because I have more than one independent variable, right? So, and this is my name of the columns of my independent variables, right? So now let me create a data frame. So I know my data is in data.data, right? And okay, now let me try to run this, right? So I'll print what this data frame contains. See, I got 0 1 2 3 up to 12, which means I have 13 independent variables, right? So I need to name these variables, right? So where do I have the name of this variables, which is in the data dot feature names, right? So I'll say this is my column names, right? So columns is equal to data dot feature names. See, got it? Now we have independent variables. Now we also need a dependent variable, right? The variable that I need to predict, right? So let me create one more column. So how many columns we have? If you see here, we have 506 records and 13 columns. So I'm going to create one more column called label, right? The one which I wanted to predict, right? And we know where our labels are present. It is in data dot target. This is my label, right? Let me delete this. Data dot target. Now I'm sorry, it's supposed to be this variable. Now if you see this, right, I have a label created. Clear? Now we'll try to understand this data. So we have very nice function called describe in pandas. It will describe each and every column, right? What it does is it will tell you the count of the records available in each column and what is the mean of the each column. So the mean of the crime is 3.6 and mean of Zn is 11, and what is the standard deviation of it for each column, what is the minimum value, what is the maximum value. If you remember, right, so when we are talking about outliers, we talked about Q1, Q2, Q3, right, quantiles, interquartile lines, right? So this is nothing but 25% is nothing but Q1, 50% is nothing but a median, which is also called Q2, and if we have 75%, it's also Q3, quantile 3. This gives you a very detailed description, right? The basic statistics which we need to start with, right? So now what we'll do is we'll try to write one the Python function, right, that calculates the missing values, the percentage of the missing values, and what is the data type of the each column, right, and how many unique values we have in that, right? We'll try to write that function. So I'll name the function as meta underscore data, right, and I'm taking an argument. The name of the argument is data. Now I need to find the total missing values. See, the very important thing, right? So when you got the data, so obviously we'll try to understand the data with the help of this. You'll see what is the maximum value, minimum value, what is the mean, all those things. The another important thing which you need to understand is if we have any missing values. It is a very crucial thing to understand. If you have a missing values, how many missing values, right? What is the percentage of those missing values, right? And if I have a categorical variables, what are the unique data available in those categorical variables? Let's say when you talk about the loan type, the loan type can be a personal loan, it can be the home loan, site loan, property loan, right? We have 4 unique categories here. So if you have categorical variables, it is good to know how many unique records are available. right? So anyways, when we are talking about the classification problem, we'll discuss more about this categorical and the uniqueness, all those things, right? So first, so in pandas, we have an function called isNull. What it does is it will check the number of nulls value for each column, and I'm summing it, right? And of course I need to find the percentage, right? So the percentage is straightforward. How I need to find the percentage? My total missing values divided by length of the data, right, into 100. Simple, right? And my data type is data dot d types. You can also try here, this is my data frame dot d types. It will tell you your CRMI is float, so mostly all your variables are integers, right? So now I need to find unique is equal to data dot my unique. Now I am returning a data frame, return pd.concat. So concatenation, you may know the concatenation, right? So quickly maybe I can say hello plus teacher. That's a concatenation, a simple concatenation, right? So now I find total percentage data type uniques, and I need to concat it, and I want to create a data frame. Clear? So now I need to have total. I'm concatenating the total percent comma data type comma unique, right? Access is equal to 1. So when I say access equal to 1, which is nothing but your columns, right? And access equal to 0, which is nothing but your rows, right? So now I'm actually creating a columns, right? So which is nothing but, so this CRM is one column, ZN is one column. In similar way, what I'm doing is I'm creating a column, right? Like total missing values, one column, and for this column I'll have the details about CRM and ZN, index, etc., right? So you'll understand in some time, right? And my keys is total missing values comma percentage comma data types. So this is the name of my columns, unique, right? Let me run this. Yeah. So now in this metadata I'm just trying to pass my data frame, data underscore LR. Now something wrong. So it says data has no object unique, where it is showing, sorry, I need to find the number of unique. So it should be n unique. It will tell you the number of unique values. Yeah, you can see this, right? So for crime, I don't have any missing values. Obviously the percentage would be 0, and this is my data type. I have 504 unique values, right? And if you see the age, strange, for age we have, okay, yeah, I thought it's a gender. Yeah, it's reasonable, right? So, and label is the one which we want to predict, right? The next important thing is, right, if you remember, right, so we talked about one of the assumption when we are trying to build a simple linear regression. The one of the assumption is your dependent variable should have some good correlation with your independent variables, right? If you don't have any correlation, then that particular independent variable won't make any sense for my machine learning model. So maybe I can simply consider to remove it, right? So we know how to find the relation between two different variables, right? So we obviously use correlation matrix, right? Equal to data underscore lr dot corr. Let me print this. Okay, maybe I'll round it to 2. Yeah. Obviously, right? So when you try to find the correlation between same variable, it would be 1, right? So now for my CRM crime and the label, I have 39% relation, which is inversely, right? Because as it's a minus, it has inverse relation. And my ZN and label has 36%, right? There are few variables, right? So if you see L, STAT, and the label has almost 74% correlation, which is very big. And then one of the variable is 70%, right? Like this. So you will be able to understand, right? So I'm sorry. So my dependent variable, sorry, my label is my dependent variable, and the remaining variables were independent variables. So with this table, I can easily understand how much I have a correlation between the independent and dependent variables, right? So the other thing is, so the other way to understand this, the correlation matrices using heat map, right? So what we'll do is we'll use a package called cbun, right? Let me import that package. Import, right? So in SNS we have a package called heatmap, sns dot heatmap, where my data is this correlation matrix. Can you see this, right? So if you see the dark colors, the light colors, which has the high correlation, obviously between the crime and crime, the correlation will be 1. Can you see this color coding, the diagonal, right? So wherever you see the light color, which means you have some good relation. Clear? So if you remember, right, in our previous video we also said, right, the one of the way to check the correlation is to printing the scatter plot, right? We'll also try to print that. For that, let me import a package called matplotlib. Import matplotlib dot py plot as PLB. So matplotlib is one of the the famous visualization tool available for Python. All the seaborn, everything is built on top of matplotlib only. So we know, so we need to print the scatter plot, right? So obviously between data underscore lr of which variable, maybe I'll take this and between this variable and my label, it has a decent correlation, right? So between this lstat and my label is minus 74%. So that's why the data is moving like in this way, in the opposite direction, right? So maybe we'll take some positive value, 70%, right, which is my RM. Okay, let me copy this, and you see the data is traveling in another way, right, because it is positively correlated. Maybe we'll see the very less correlation. Yeah, CHAS has very less correlation, which is 18%. We'll try to plot how it's bad. All right, so there is another option in the seaborn. Instead of printing the each and every between each and every variable, so we can print a pair plot. So there is an option called pair plot in SNS. Pair plot. So this is my data underscore lr comma my x variables, which is my independent variables, right? So CRIM age. I'm just randomly selecting some values here, no specific, and my y variables will be obviously label. Between the label only I want to check this relation, right? What happened? Okay, maybe INDUS. Let me see this. Yeah, I misspelled it. Can you see this? This is very straightforward, right? Instead of printing for each variable, right? So this would be very straightforward, right? Now what I'm trying to do is, now I want to remove the variables which has a very less correlation with my label, or with my dependent variable, right? Remove the variables which has very less correlation with my dependent variable, right? So let me create a new variable name called data new is equal to, so data, so we have a method called drop. What I need to drop, so maybe, yeah, this has very less correlation. Obviously this is one of the variable which I want to drop. The another one is maybe this has 25%. maybe we'll also try to remove this dis. The another one was maybe, we'll check, 33. maybe we'll also try to remove this d. Yeah. Now I need to remove the columns, right? So let me run this. We got an error. The error says not found in access. By default the value of access is equal to 0, which is my row. What I'm trying to delete, I'm not trying to delete a row, I'm trying to delete a column. So I should explicitly say to my pandas saying that, hey, this is not a row, this is a column. So I should say access equal to 1. Now if you see this new data, I don't have those values, I mean the variables which I just deleted. Right? Now if you remember, right, so in one of our video where we are talking about the accuracy, how to calculate the accuracy, for the regression, so we talked about trained data and the test data, right? So now, so when I want to build my the machine learning model, right, I build my machine learning model. Obviously I need to test how it is performing, how accurate it is, right? For that I need some other data set where my machine learning model never seen that when during the training, right? So in sklearn we have some methods to split the data into train and test. Model selection, input, train, test, split. Right? So obviously we have x-axis and y-axis. My x-axis would be obviously other than label, right? Because label is my dependent variable, my target variable, the variable which I want to predict, and it would be in the y-axis, not in the x-axis. So I'm just dropping that column. Label. Obviously we know why we are saying axis, right? And also the similar way I need y. My y is nothing but my label, right? Clear? Now what I'll do is I'll use this method, a function, to split my data x comma y. I'm saying my test underscore size is, I think I need to run this, I'm not sure if I run this, yeah, 0.2, which means my test size is 20%. Obviously my training data set will be 80%. Clear? So now we'll get some response from this value, right? So from this method or function which we need to store in our variables. This is how the sequence will be. first I'll get the X training data, and then I'll get the X test data, and then I'll get the Y train data, and then I'll get the Y test data. So this is the sequence how this function returns, right? So we have to follow the same structure, obviously, right? So now we are good to build a model, right? So we use in the same sklearn dot linear model import linear regression. First, let me try to create an object for my linear regression. Yes. Now what I need to do, this linear is in an object, right? A linear regression algorithm object, maybe, I mean, for understanding purpose. So now for this object, I need to pass my training data and tell, hey, with this data, you train yourself, right? So how I do is I'll say this object dot fit. I'm fitting with my obviously X train comma Y train. Clear? Now this linear is my machine learning model. You can very well see the coefficients. We know what is the coefficients, right? So minus 0.1 is my coefficient for CRM, which is nothing but my slope, and 0.012 is the coefficient for Zn. Clear? You can also see your intercept, which is nothing but your C, right? Which is 32. So which means this is the line when you draw a line. So at the 32th point in the y-axis, my line crossed. So that's my intercept. Now we actually need to find the accuracy, right? Obviously I need to find the accuracy of my model, right? So this is the linear regression machine learning algorithm model, where we stored in a variable or object called linear. So now let's try to find the accuracy on your test data. It's simple. Test predict equal to your linear dot predict. Predict is one of the method. So what I need to do, I need to pass X test, which is my test data. I'm sorry. So I obviously need to pass the test data, X test, not Y test. Why? Because if I pass the X variable, it has to predict the Y variable, right? Clear? That's why here I'm not passing the Y value here. Y is the one which it is going to predict now. So if you see this test predict, yeah, this is your Y variable, I mean the predicted result, and we have the actual result where in Y test, right? Now with the Y test and the test predict, I can find accuracy, right? In our previous video, that's what we did, right? So we talked about R square, adjusted R square, mean square, all those things, right? So we'll try to import those methods. So we in the matrices import mean, squared error, comma R2 score. This is what I'm interested to find, right? So my R2 for test data is equal to R2 score. So into R2 score, what I need to pass? I need to pass Y test data and my test predict data. So on my test data, my model gives 73% of the accuracy. I can say this, right? Now we'll try to find the, I will try to predict by our machine learning algorithm on the scene data, which is my training data. We discussed in our previous video why we need to do that, right? So predict on the scene data. So we have to follow the same steps. So instead of test I'll say train, instead of x test I'll say x train, right? So obviously r square for instead of test I'll give train predict. This would be my y train. My r square value is 68, close to it, right? Close to my R2 score for the test data, right? So let's say my R square for my scene data, right, is, let's say, it's somewhere around 80% or 85%, and my R square for the test data, the performance of the test data, is somewhere around 60, which means my model is predicting very well on the scene data, but it is not good on the unseen data, right? So we call this problem as an overfitting problem, right? Which means my model is trained overly on my scene data, which is my trained data. Because of that, it is not able to predict the unseen data. The second problem is my R square for the test data and the trained data will be very less. Both the cases my R square is very less. So in that case, we call it as an underfit. We call it underfitting. So these two are the major problems, overfitting and underfitting. So I'm repeating again, overfitting means, so on my train data, my model performed very well, but on my test data, my model performance is very poor. We call it overfitting. When you talk about underfitting, both on the train data and test data, my model performance is very poor, right? So there are many options where we can overcome this overfitting and underfitting. So when we are talking about the tree based algorithms, we'll touch about this a lot, right? So yeah, maybe in our next video, right, we'll talk about the feature selection. So whatever the feature selection we did is based on the correlation, right? So there are few other parameters, right, where you can say whether this particular variable, so this crime and label has very good correlation, let's say, but still I need to know whether it is really significant or not, right? So those part we'll try to cover in our next video. So hope you enjoyed this video. So we'll be in touch. Stay tuned. Thank you. Bye bye.